Hello dear students. So now in this session we will learn about that how we design the shift register using the flip flop. So as we very well know that we are using the D flip flop for the designing of shift register, and shift register is what it is used to store the 4-bit data. Okay. So as we are using the 4-bit number for we are using the 4 shift register, and these 4 registers can be these 4 flip flops can be used to store 4-bit numbers. One bit number can be stored by a one flip flop. Okay, so that's why we are using the 4 flip flop for storing the 4-bit data. And in this session we will learn that how we design the shift register by using the 4 uh, D flip flops. Okay, so now let's see. So here the first thing is, first of all, save the screen by writing the name shift register. Shift register. So in order to perform this experiment, we are having a requirement of breadboard. The breadboard. So put the breadboard on the left side screen. This one is the breadboard. Okay, and after that, the next thing is what? The next thing is the 7474 IC. 7474 IC we are using for the D flip flop. Okay, so that's why we put that IC on the breadboard. So we very well know that in the IC we are having the 2 flip flop. One flip flop occupied the left side position, and the another flip flop occupied the right side position. Okay, so here we are using the 4 flip flops. Okay, so in order to store the 4-bit data, so that's why we are using the 2 IC. Okay, so 2 flip flop on this IC and 2 flip flop on this IC we are using. So after putting the IC, first of all we first connect the 7th number pin to the ground. So we consider that the this layer of the horizontally sorted slots for the ground connection. So that's why, and giving the color to the wire black, and same thing on this IC. We connect the, just a minute, we connect the 7th number pin of this flip flop to the ground, and after that we very well know that the 14 number pin of the IC is connected to the power supply. So for the power supply we very well know that it is connected to the power supply and giving the color to the wire red in this manner. Okay, so after that, search in the search bar for the power supply. Search in the search bar for the power supply. So this is the power supply we are using. Okay, so here the negative terminal of this is connected to the negative layer of horizontally sorted slots. Okay, and giving the color to the wire black, and after that the positive terminal we connect to the positive layer of horizontally sorted slots and giving the color to the wire red. After that, now we connect the means the negative layer of horizontally sorted slots to the negative layer, because we are using the both the slots together. That's why we sorted these slots. And after that, giving the color to the wire black for the negative, and for the positive, we connect the positive layer of the horizontally sorted slots together in this manner, and giving the color to the wire red. Okay, so now the connection is, now the next one is, we are this one, this one is our what, this one is our reset one. Okay, so this is the reset one of the this one is the reset one of the flip flop first, and here on the next side you see that this is the reset second of the second flip flop. Okay, so but as I already telling you in the session that the reset pin of the reset pin of the flip flop is always connected to the logic 1. Okay, and as these are internally connected to each other. Okay, reset of the flip flop 1 and reset of another flip flop are connected, internally connected to each other like this. Okay, and after that we connect the wire and connect that wire to the power supply in this manner. Okay, and after that, now this one is the set one. Okay, so as I already telling you, the reset and the set both are connected to the logic 1. So here the set 1 of the D flip flop 1 and the set of the another flip flop. Here you see that mentioned here set 2. Okay, so the set 2 of the another flip flop is now connected to the are shorted to each other, and both are connected to the logic 1, right, in this manner. So now here you see that this is the output 1. Okay, so as we very well know that in order to connect the, so let me show you screen, let me show you the screen just a minute. As I already telling you, so here you see that in this logical diagram, you see that the output of one flip flop will be the input of another flip flop. Okay, so same thing we will make the connection like this. Okay, same thing we will make the connection like this, means we connect the output of one flip flop to the input of another flip flop, and after that the output of second flip flop we connect it to the output of another flip flop, and output of this flip flop will be connected to the another flip flop, and side by side we connect the output to we connect the output of each and every flip flop to the LEDs. Okay, connected to the LEDs. Yes, but now is this thing clear to you that I want to tell you? Is that thing clear? Yes, is this thing clear? So now what we do, the output of this one, this is the output of first flip flop, that is connected to the input of another flip flop, this one. Okay, and here for the output we now using the LEDs. This is the LEDs for the output. Okay, these are the LEDs for the output we are using. This is the LED. Actually we are using a 4-bit shift register, so that's why we are using the 4 LEDs, and this is the resistance, and you take the value of the resistance, you give the value of this resistance to 220 ohm. Okay, and after that you see that this one is the output, this one is the output 1, and that output we connected to the input of another flip flop, and also we take that output, we connect that output to the output of the LED. And for the output we are using the green color wire. Okay, and after that, as this output is already connected to the input of our second flip flop, and here the output of this flip flop, okay, the output of this flip flop we now connect it to the input of our third flip flop. Input is this one, we connected is this, and for making the connection we are using the different color wire. Okay, this is the output, this is the input of this one. Okay, and here we very well know that this is the input and the output of this flip flop third. Okay, this is the output of the flip flop third. Okay, that output we now connect it to the input. This is the input of the fourth one. Okay, this is the output of the flip flop fourth one, input of the fourth one. Okay, so now what to do, we make the connection. So here this one is the output second, we also connect the output second to the this one, this one LED, and for the output we are using the green color wire. Okay, so here the output, this one is the output of the third flip flop. That output third will be connected to the input of our fourth flip flop. Okay, and that output of the our third flip flop we now connect to the input of the this one. Okay, and here this one is the output, this one is the input, and this is the output of the fourth flip flop, and that output of the fourth flip flop we now connect it to the LED that is connected to the output like this. Okay, so now what to do after that? So this one is the reset button, this one is the reset pin. Okay, so that reset, just a minute, that is the reset, this one is the reset, and that reset is connected, means internally that reset is internally shorted to the reset of the another flip flop, and giving the color to the wire red. And here the reset is always connected to logic 1, as I was telling you. And here this one is the input that I already give the input to this, and here this one is the for the clock. So I will tell you that how we give the clock. And here this is the set button, set pin. So set we internally connected to the internally shorted to the set of another flip flop like this, and the set is at pin number 4, and that is connected to the logic 1 like this. Okay, output is connected to the internally connected to the another flip flop like this, and after that this output of the third flip flop is connected to the input of another flip flop, and here that output is connected to this one. This inverted input is always left blank. Okay, so now after making the connection, so what to do? So here this is the clock input. So the better clock input we connect means internally connected to the our flip flops, this one. Okay, internally connected to the another flip flop, and this is the clock input, this is the clock input. That clock input we connected to the next means internally shorted to the next clock input, and after that we are using the slide switch. We are using the slide switch for giving the input and for providing the clock input. Okay, for providing the clock input like this. So here this is our slide switch, and we very well know about the slide switch connection, that the first terminal is connected to the power supply. The last terminal is connected to the ground. Okay, so the ground, you can give the color to the wire black, and the middle one, this one is for the our clock input. This is the clock input, pin number third. This one. Okay, you can give the orange color wire for the input, and here that clock input we also connect it to the pin number third. We also connect it to the pin number third, this one. Okay, of the next flip flop, like this. So after that we are having the input. Okay, so that input we will provide by using this push button. So then first input is connected to the power supply, the last one is connected to the ground, and here the middle one, that middle one will be given to the our input, that is at pin number second. So hence the connection is now complete for the flip flop, for the shift register. Yes, but now up to this point, the thing is clear to you that how we make the connections. Anji, I only get the response from one student. So now, bete, so let's see the timing diagram first. So here you see that in the timing diagram. So at this time, our clock input is 0. So as I was telling you, then the clock input is 0. So let's see the screen. So but here you see that at this time, the clock input, the here this is the clock. Okay, this one is the clock. Just a minute. This one is for the clock. Okay, and this one is for the input, or say serial input. Right, bete? So here this one. So at this time, the clock input is at 0, and the serial input is also 0. So that's why the QA, QB, QC, and QD both are at 0 0 condition. Okay. So here this one is our QA, QB, QC, and QD. So here at this time, when the serial input is at 0 condition, just a minute. So here you see that at this time the serial input is 0 and the clock input is 0. So under this condition the outputs is at 000 condition. Okay. So let's see, as we make the circuit for the positive trigger. Okay. So here when the clock input you see that when I give the signal and at the positive trigger, and when we give the clock signal, so at this time the QA will glow. Okay, the QA will glow. So here when I turn on the power supply, okay, and giving the clock input, so here you see that our QA will glow at this time. Okay, our QA will glow at this time. So after that, at the next positive trigger, at the next positive trigger of the wave, and when we turn off the serial input, so what happens? So under this condition, the QA will be 0 and QB is 1. Okay, so let's see. So when I turn off this serial input and apply the next clock input, the positive trigger, our QB will be 1 under this condition, right, Bete? And after that, the next input, next clock input, this one is the positive trigger. So here at the positive trigger, the value of the SI is now you see that 0, and QA, the value of QA will be 0 at this time, and the value of QB is 0. Okay, when we apply the third clock pulse. Okay, so here when we apply the third clock pulse, this is our third clock pulse. So at the third clock pulse, our QC, our QC will be 1 under this condition, and the remainings will be 0. Okay, and at the fourth positive trigger, the value of QD will be 1 under this condition. Okay, so here the value of serial input is 0 at this time, and when we apply the fourth clock pulse, so here you see that our fourth fourth output will be 1 under this time. So here we see that the data is transferred from QA to QD. Okay, in the sequence. So that's why I mentioned here. So here this one is what? This one is our QA. This is our QA. This one is our QB. This is our QB. This one is our QC. And here this one is our QB. So hence the data is transferred from QA to QB. This is all about the uh, our experiment of the shift register. Hence the data is transferred from the QA to QB in the shift register by using the D flip flop.